Hi and welcome to our Fluid Mechanics Laboratory presentation regarding Experiment 2 Center of Pressure, and our lecturer is Dr. Afiq. Our group member consists of Ang, Chengyu, Gan, myself, Nicole, and Haikal. Now let us jump straight into introduction. Firstly, the study of the center of pressure is an essential concept in the field of fluid mechanics. Then the center of pressure is actually the point where the total hydrostatic force acts on a submerged surface. Next, the aim of this experiment is to determine the center of pressure and also its hydrostatic force. The reason being the center of pressure is an essential concept is due to the fact that it is actually a very vital concept in many engineering fields, especially in the hydrodynamic field. Moving on, we will look into the objective of this experiment. Moving on, the main objective is to determine the center of pressure and hydrostatic force due to the fact that water acting on a partially and also fully submerged vertical surface.
Hydrostatic force is a force exerted by a static fluid on a fully and partially submerged object. Its magnitude and direction depends on the object's shape, size, depth of immersion, and fluid properties. Hydrostatic force on a curved surface is perpendicular to the surface and can be resolved through the pivot points. Hydrostatic force on a vertical submerged surface is counteracted by a balanced weight. Its resultant force determined by the balanced weight and the water depth. For equilibrium conditions, the moment generated by the hydrostatic force and added weight must be equal for equilibrium. This is to ensure the balance around the pivot points. Position denoted by the center of pressure, expressed as a particular distance from the free surface. In this experiment, there are two conditions, which is partially submerged quadrants and fully submerged quadrants. From this figure, we can see that C is represented as centroid, P is equal to center of pressure, V is width of the quadrant surface, D is the depth of water for the base of the quadrant, and H is the height of the quadrant surface. The equation on the right side is used to calculate the hydrostatic force, theoretical values for center of pressures, experimental center of pressures for partially submerged quadrant only. For the cases of fully submerged quadrant, it is quite similar to the partially submerged quadrant, except the equation is applied. So for the hydrostatic force, theoretical center of pressure, experimental for the fully submerged, we apply the equation as shown here.
Next, we move to methodology. This is the experimental setup to determine the center of pressure and hydrostatic force. This consists of rectangular transparent water tank, a protected quadrant, a balance arm, an adjustable counterbalance web, and water level measuring device. First, measure the dimension of quadrants vertical endplates B and D and the distance H and L, where B is width of the quadrant face, D is height of the quadrant face, H is vertical distance between the pivot and the base of the quadrant, and L is the length of the balance arm. Next, clean the quadrant by using a wet cloth. Place the equipment on the surface level and adjust the counterbalance until the balance arm is horizontally aligned with the level indicator. Position the balance arm of the knife edge and make sure it moves quickly. After that, place the weight hanger on the end of the balance arm, and the arm utilizing the counterweight is level until the balance arm is horizontally level. 50 grams is added to the weight hanger. Add water to the tank and allow to settle. Shut the drain valve and gradually add water until the hydrostatic force on the quadrants and surface is balanced. This can be determined by aligning the balance arm's base with the level indicator. Record the water level in millimeters as displayed on the quadrant side. Repeat the steps with an increment of 50 grams each time until the water level reaches the top of the quadrant surface. Repeat the procedure in reverse by progressively removing the web. At the end, release the water valve, remove the web and clean up any spilled water. To prevent accident during the experiment, a few steps need to be done. First is wipe the corner with a wet cloth to remove surface tension and prevent air bubble from forming. Besides, place the apparatus on a surface level and adjust the screw in fit until the built-in secure spirit level indicates that the level is horizontal. We should position the balance arm of the knife edge and check that the arm swings swiftly. Align the base of the balance arm with the top or bottom of the central marking on the balance rest in order to make sure that the hydrostatic force on the quadrant and surface is balanced.
During the experiment, we obtained that the width of submerged B is equals to 0.075 meter, the height of quadrant and face D is equals to 0.1 meter, distance from base of quadrant to pivot H is equals to 0.195 meter, length of balance arm L is equals to 0.285 meter, area of the quadrant A is equals to B times D, then the final answer we will get 0.0075 meter squared. And last one, the density of water rho is equals to 1000 kg per meter cube. So based on this data we obtain, we can generate four graphs, which is hydrostatic force versus depth immersion, theoretical depth of center of pressure versus depth of immersion, experimental depth of center of pressure versus depth of immersion, and the last graph is mass versus depth of immersion. From the figure 5.1, which is the hydrostatic force graph, we can see that the hydrostatic force is increasing linearly with the depth of immersion of the quadrant. This condition corresponds to the relationship between the pressure exerted by the waves and the increment of depth of immersion. The greater the wave of fluid is above the submerged quadrant, the greater the pressure is exerted on it. It can be logical that the hydrostatic force increases when the pressure exerted increases, as force is directly proportional to the pressure. From the figure 5.2 and 5.3, it can be observed that both theoretical and experimental depth of the center of pressure decreases when the depth of immersion decreases. The lower the depth of immersion, the lesser the wave of fluid is above the submerged quadrant. Thus, pressure exerted on the submerged quadrant is lower. The gradient of the graph becomes less steep when the depth of immersion reaches 118.5 mm and above, because there is additional depth of immersion after the quadrant is fully submerged. Besides, the experimental data for the depth of center of pressure is higher than that of theoretical values. The area of the data range is considered low, which is only from 4.21 to 8.87%.
After analyzing the discussion, here are a few justifications for the error that occurred throughout the experiment. First, parallax error is actually a significant source of human error when measuring the depth of immersion. Therefore, to minimize this error, two group members will take reading for each value and record the mean value in order to increase the accuracy of our result. Next, during the experiment, there will be accidental splashing of water onto the balance arm, especially when one group member is pouring water into the tank. Therefore, this can actually affect the experimental depth of immersion reading, hence causing the result to be less accurate. Last but not least, the loads and the load hanger were actually not weighed before conducting the experiment, hence the accumulation of dirt and oil throughout the time on them may have increased their mass slightly. However, we are not sure of the source of this. As a result, the weight of the balance arm would increase and hence also lead to inaccuracy in our result. However, this can be minimized by weighing them before we conduct the experiment.
In conclusion, the center of pressure is a point on the immersed surface at which the resultant hydrostatic pressure force acts. From the graph shown, hydrostatic force is directly proportional with the depth of immersion. The hydrostatic force on the center point occurs when the balance arm becomes horizontal, and the water level is supposed to be lower if the weight increases to get the balance reading. Larger error percentage is when the weight value used is small, while the error value is low at the large weight value. In terms of analysis, result and data, the hydrostatic force becomes higher when the quadrant is still in a partially submerged position, so the force applied to the submerged surface is low. The hydrostatic force becomes lower when the quadrant has reached a fully submerged position, so the force applied to the submerged surface becomes greater. Last but not least, these all are the reference from different sources that we use in conducting the lab report for this center of pressure experiment. We use this reference in terms of theory, calculation, formulas, and conclusion. So that's all for our group presentation regarding open-ended experiment. Thank you.